This is the final lesson in our 6-lesson series on coordinate geometry, otherwise known as analytic geometry. Today we're going to talk about how we classify special quadrilaterals on the coordinate plane. So a quick review of some vocabulary. Quadrilaterals have 4 sides. So a quadrilateral is any 4-sided polygon, and we have a special family inside the quadrilateral family, which is the parallelogram family. This is the one that we focused on in school. Parallelograms include rectangles, rhombuses, and squares. Quick review of definitions. A parallelogram has 2 pairs of parallel sides. A rhombus has 4 congruent sides. A rectangle has 4 right angles. And a square has 4 right angles and 4 congruent sides. It's defined to be both a rectangle and rhombus. So all of these are parallelograms. A trapezoid, we talked about the definition of having 1 pair of parallel sides, and then an isosceles trapezoid would also have congruent legs. Kites, we also mentioned, had 2 pairs of disjoint congruent sides. So we're going to focus on the parallelogram family, but we also can determine whether or not something is a trapezoid by checking to see if its sides are parallel. So in the next section, we're just going to do a quick review of properties, and also we're really looking at tests for particular shapes. So the parallelogram, we are looking for 2 pairs of parallel sides. If I want to show that something is a parallelogram, I can look for 2 pairs of parallel sides. You may also remember that 2 pairs of opposite congruent sides is a test to prove something is a parallelogram. And additionally, we can also prove that if diagonals bisect each other, that would prove that something is a parallelogram. To prove that something is a rhombus, we need to show 4 congruent sides. That's the definition. To show that something is a rectangle, we need to show 4 right angles. Remember, a right angle is going to be shown by perpendicular sides. And then for a square, we need to show that something is both a rhombus and a rectangle. So let's get started. In our first example, I'm being asked to classify a quadrilateral as specifically as possible. That means as far down on my chart as I can. So I'm going to start with just sketching what the given information. So this shape looks like maybe it's a trapezoid, but it's unclear. I'm going to need to make some calculations. And I'm going to determine whether or not there are any parallel sides by calculating all of the slopes. So this first side over here, my change in y is from 1 to -2, that's down 3. And x is from -2 to -1, that's a positive 2. So my slope is -3/2, and I can't simplify that. Next, I'm going to calculate this slope here. I know I'm going up from 1 to 3, that's a rise of 2. And I am going over from -3 to 0, that is a run of 3. Over on this side, I have my rises. I'm going to go down 1, and I have a negative slope, so I'll stick a negative out here. I'm going down 1, and I am going to the right 5, so -1/5. And then finally, at the bottom, I am going from -2 to 2, that's a rise of 4, and a run of -1 to 5, that's 6, so I have a slope of 4/6. So what I'm looking for is to determine, are any of these slopes telling me that I have parallel lines or that I have perpendicular lines? It is really important that you simplify your slopes, because otherwise you might miss that 2/3 and 4/6 are in fact equal. So since they both have a slope of 2/3, we know that this is a trapezoid. And this is because it has 1 pair of parallel sides. The next thing I need to check is whether or not the legs are congruent. That way I'll know if it's an isosceles trapezoid. And to check whether or not 2 things are congruent, I need to find their lengths. So I'm going to find the lengths of the 2 legs to determine whether or not they are equal. So this leg, I know that I'm going to use the distance formula, and the length is going to be the change in y and the change in x squared. So my change in x is from -3 to -1 is 2. My change in y is 3, and that gives me a square root of 4 plus 9 is 13. Over here, the other leg, I have a change in x is from 0 to 5, so that's 5 squared, and my change in y is from 3 to 2, so that's 1 squared, and that gives me a square root of 26. So I now have the evidence to tell me that my legs are not congruent because they do not have the same length, so this is not an isosceles trapezoid. The one other thing I just want to point out to you guys on this video is that, in fact, even though I didn't draw my figure perfectly to scale, my slope calculations tell me that these are in fact right angles. So just to keep in mind, in this case it's still a trapezoid because I don't have two pairs of parallel sides, but just remember that 2/3 and -3/2 would tell me that I have perpendicular lines there. In our next example, we are given 3 vertices for triangle RST and asked to prove that it is a right triangle. So I'm going to start by sketching what I know. So now that I have my triangle, again, I am going to find my slopes so that I can determine where my right angle is. So I am looking for the slope of this side and the slope of this side because I'm pretty confident that this is where I want to show is a right angle. So the slope of my left side here is I am going down 10 from 6 to -4 and to the right 6 from -5 to 1. And over here, my slope is going from -4 to -1, that's up 3, and to the right 5. So when I glance at that, 3/5 and -10/6, I can see that those are in fact opposite reciprocals because -10/6 simplifies to -5/3. So I now have a slope of -5/3 and a slope of 3/5, which shows me that RST is a right triangle. So I would say that RS is perpendicular to ST because their slopes are opposite reciprocals, which makes the consecutive sides perpendicular. So the next thing we're being asked to do is give coordinates for some point P, which we don't know, so that RSTP is a rectangle. So we're trying to create a rectangle here. So I would recommend pausing the video, see if you can figure out where you would put, and then turn the video back on once you think you've got the point and we can prove it together. So my approach to this problem is that I know I need to create a point P that comes between R and T. So it's going to be somewhere in this area. To figure out where it is, I'm going to create a line that is perpendicular to ST and perpendicular to SR, and I'm going to find where those intersect. So I'm going to start by going up from T. I know I need a line perpendicular to a line with a slope of -5/3, so I'm going to make that 3/5. So up 3/5 gets me here, and now I'm going to draw the line through those 2 points. I'm going to do the same thing with SR. I know that slope is 3/5, so I'm going to do a -5/3. So I'm going to go up 5 and back 3. Make sure that's negative. I'm going to do it again. Up 5 and back 3. And now I am at the same point I was before. So I can see that this point is where those 2 lines intersect. And the coordinates of that point are 2, 4, 6, 8, 9, 0, 9. And so now that I found my point, I need to prove that this actually is a rectangle. So I constructed this to be a right angle. I constructed this to be a right angle. And now we just need to show our reader that this is also a right angle. So we know that at point P, we have a line with a slope of 3/5 and a line with a slope of -5/3. So we can now conclude that those lines are perpendicular and therefore form a right angle. And then we can just write up why we know that this is a rectangle. So we would just write up where P should be placed, and then proving that our STP is a rectangle, we would say that we would write our new slopes, and then we would say consecutive sides have opposite reciprocal slopes. Therefore, by definition, our STP is a rectangle because it has 4 right angles formed by parallel sides, by perpendicular sides. So remember, our objective today was that we would be able to write the equation of a line and a parallel perpendicular line. So just a reminder that our objective today was to be able to validate properties about special quadrilaterals and use those special properties to determine information about lines on the plane.